Okay, we're at the back of the house. We're going to go around counterclockwise. So I just kind of like start like this. And this is the garage car entry, of course. And this is the brickwork above it. We have a lintel. This is a metal lintel. Okay. And we have disrupted the drainage plane from the brick. Anytime you have brick, when it comes down, like right here, that's called a weep hole. You see, brick is a very good building material. Okay. This home could burn down and you could reuse the brick, or it's a very good insulator for sound and for temperature. So and brick is unless you paint it, it's a maintenance-free system. Okay, you might have to repoint it every once in a while or do a little bit of routine maintenance, but it's relatively zero maintenance. Good insulator, a lifelong product, but it's porous. It's porous in water. You'd be surprised how much water. Architecture is regional. You'd be surprised how much water when it rains, when the lawn sprinkler system hits it, when those things happen. You'd be surprised how much water gets through there. And then it escapes through weep holes around the foundation perimeter. Okay? Those are there by design. We need those. Most of the time, the only thing that comes out of those is vapor. I get that. Most of the time, it's just vapor. But if you have an incident, water will come out of there. But the drainage plane has been disrupted by the foundation. The water has to have some place to go because the brick is porous. We have altered our drainage plane by installing a lintel above the garage car entry. And by the way, they're supposed to go at least 6 inches past the door. I don't know how far that one went. Okay, it makes me kind of wonder because this one goes a foot. This one goes a foot past it. I can tell how far that one went. So did the lintel? I can't tell. Is the lintel extended far enough through the brickwork? That's an unknown. I can't tell. But what I can tell is that we do not have any weep holes at the lintel because we've disrupted the drainage plane. The water that comes in the bricks got to come down to this and works its way out like that. We should have lintels right there. Wooden windows don't need lintels. All right, wooden paneling, they don't need lintels. So that's something else. We got a little bit of impact damage on our rain gutter, and it goes on up. So I can see some hail damage on our soft metal. Now the brick, another characteristic about brick is it grows. You'll never be able to measure it, but it's the only part of your house that actually grows. The concrete, it dries. In 60 years, it'll dry. I think that's how long it takes concrete to dry. 100%. It dries 90-something% in the first few days. And then it slowly dries, gets hard, cracks, we got all that. Well, when it dries, it shrinks. Now, brick and concrete slab foundation and brick walls have different physical properties. They expand and contract in relationship to the weather at different rates. So they're always moving, they're always fighting against each other, and the stress always comes out at the corners. I'm going to get there. Stress always comes out at the corners. A lot of people call those corner pops. Those are actually shrinkage cracks. Call them what you will, but that is not a foundation issue. That being said, if the corner pops all the way out, you might lose a brick or two, but it's not a foundation issue. I haven't made up my mind about this foundation yet, but this won't factor into it. Now, if that pops out, now you're holding up your brick. Your brick is a fascia because you have a drainage plane behind it. So you might want to keep your corners intact so that you don't, have movement in the bricks. Also, these cracks are known to facilitate the entrance of subterranean termites into your structure. So this is a conducive condition. It's not by design because it's cracked. Texas Structural Pest Control Board says that I got to call that a conducive condition. So, corner pop, shrinkage crack, a little bit of damage. Over here we got a whole video about our grounding rod. One thing, this is our control wires for our lawn sprinkler system. It's kind of capped off, but that should have been continuous. Even though it's capped off like that, the conduit should have been continuous coming up here to protect it. Should be sealed on 3 sides. These disconnects should be sealed on 3 sides. Your grounding rod has not been properly buried, and it is corroding. It's coming apart. Moving on along, we got a little bit of wood mulch right here. This is as good place as any. Where do termites live? In the ground. Oh. What do they eat? Dead wood. Oh. What's wood mulch? Dead wood on the ground next to your house. It's called a clue. About 3 times a year, I'll just come over here and do a Hail Mary pass somewhere around a house, and I'll find termites. No telling how many termites I've walked past and never saw. Over here, this tells us, these little round circular things, that this is a post-tension slab foundation. What they've done, and there's several types of post-tension slabs. I don't know which type this is. They're all good, all suited for the purpose. All, you know. The cable makes the foundation much stronger than conventional rebar. So there's that. And so we just know. Now we come over here, our rain gutters do not divert water far enough away from the structure. And then over here, we've got a regular swamp going on. We don't have drainage. Well, if it's 10 feet away from the house, and it doesn't affect you, bud. Well, it doesn't affect me at all. You're right. It doesn't affect me. Will it affect my client? You want your kids and your dogs walling around in that? You want mosquitoes in there? You want a good dose of West Nile disease? That's something to think about. Moving on along. We've had some repairs. This is the kitchen. This is a sewer pipe. Why has the sewer pipe been repaired next to the kitchen? Why is that? It doesn't match. I know it's been repaired. Rain gutters, weed whackers hit some of this, but if you go up farther, a weed whacker didn't get here. We've had hail here. Now, 2 things are happening. This house has experienced hail, and the roof was not condemned, or the house has experienced hail, and the roof covering was replaced, but they didn't replace the rain gutter. Roof covering and rain gutters last about 14 years. I haven't looked at the roof yet, but if this roof is a recent replacement, I doubt it is, but should it be, then you're going to be piggybacking. The rain gutters will wear out before the roof will wear out before the rain gutters. It's better to get something like that done all at once, but we're going to look at that. A tree should not be closer to a structure than 25 feet to allow root growth. And the roots will come in, they pull the water out from the house that you need. Okay, the roots will grow and they'll exert pressure on their foundation that you don't need. The trees will grow into your house and wreck your roof and your walls, and they're just a nuisance. I get it, they're kind of cute. This is a crepe myrtle. You can't kill this. You could cut that crepe myrtle down 6 inches above the ground or less, and it would sprout back up. You still have all the roots and stuff, but it wouldn't be rubbing against your house. But yeah, trees, I get it. It's an ornamental tree, whatever. It's too close. Wood mulch, too close. Okay. Going along. Oh, by the way, back up here a little bit. Have you got enough time to hang with me? This is the largest crack. I don't even want to call it the most significant crack, but this is the garage. This is a nice long wall. It's brick. We expect it to move. We don't have but one control joint way down there. Probably should have had control joint right about here, because it made one. We got a crack right here going through the brick and mortar. This is the water heater temperature pressure relief valve leaking. I'm going to mention it one other time, at least. Moving on along. Another shrinkage crack right there. Wood mulch next to the structure. This is even a better example because we got some bricks over there. You can like make allowances or excuses or do something. Over here it's pretty evident that the wood mulch goes straight to the house. We've also got a lot of leaves in this, so wood mulch and debris. Too close, too close, too close. Moving on. Now most of the roof is asphalt. shingles. But we got a little bit of a roof right there that's metal, standing ridge, metal panels. But this is what I want to look at. Look at the hues. Look at the colors. Now let's just rotate over here a little bit. Look at the difference. You see these carriage lamps? These wall sconces? See how dusty this one is? See how dark this one is? See the way the roof covering comes to this point? All the water comes off the roof there. All the water comes off the roof, comes to this point. Anytime a roof, I don't know how to fix it, that is called a dead valley. It's by design. Rain gutters are not supposed to discharge water on top of the roof, so you get all the water coming from all of this roof coming up here. That roof there and that roof there, all coming down to this point. Okay, that creates a dead valley, which is a problematic design, but there it is. Now, technically, you're supposed to have kick-out flashing. I don't think kick-out flashing is going to help you one bit right there, but usually where the roof covering and the walls make a junction, where they come together parallel. I'm looking for my geometry terminology here. It'll come to me in a minute. So, but we don't have any flashing that's kicking it farther out. Now, the rain gutter itself, the butt end of the rain gutter is not supposed to be closer than 1 inch, 2 inches to the brickwork. So what we're looking at here, let's study this here for a little bit, is all that water coming down in here, meeting at this point. Brick is porous, remember? And it's all coming down this wall. You can see where the water is just migrating down the wall right here. I'll put the cover back on. You can see how and we've had some rain here. I haven't run the lawn sprinkler system yet. You can see how the water is just seeping from behind the brick because we don't have a weep hole, so it's making its own weep hole. See the moisture coming through there? We're going to have to do some moisture readings on the other side of the wall right there to see what we can find. That's pretty amazing. Now, your electric your sconces, your wall sconces, all your exterior luminaries, they should be sealed where they're attached to the wall to help prevent moisture from coming in through there. Got a little bit of a gap right there in our flashing. You think water can jump right up in there? I do. And then our edge flashing, we come up here, it's not supposed to have less than a 2-inch gap. That looks like a less than a 2-inch gap to me. So it's not supposed to have that size of a gap right there. Now, I was talking about weep holes and making our own weep holes. We got a little bit of movement right there. I was talking about those things, but we've come over here and we got these keystones and we got this masonry brick right up here. So the weep hole should go somewhere above these. You wouldn't put a weep hole right in there on this one. And again, it's kind of like, what are we going to do with our kick-out flashing over there? I'm not sure exactly what the solutions are. We also got, by the way, some of this will be in the report and some of it won't. Let's see, the water's coming out from right there too. It's not coming out over here. But we got a nice, pretty good movement crack right there. And then, if you look, the more you look, the more you see. I don't know if you can see this. Let me see if I can get my flashlight out. It's kind of interesting. Kind of interesting. Bear with me. I'm here. Look at the gap on the lintel. That lintel gap, and you come over here, it's real tight. I don't know what that means, but look at the cracks going down this, and we expect some separation. I'm not expecting the water to come through like that. On electrical receptacle outlets, exterior electrical receptacle outlets, they should have in-use covers so you can plug in your Christmas lights and just close the in-use cover and have power and be protected from the rain. As it is, we just have these little guys right here. At one time, they was acceptable. And another time, somebody had decided that they were protected. But I don't think that's an arbitrary decision, whether it's protected enough. What's going on here? No GFCI. And hot neutral is reversed. Get my notes out. Front portico receptacle is not GFCI protected, and it's got reverse polarity. And gaps around the masonry details at the front portico. Moving on along, we got a whole video talking about the gas line and its corrosion over here. Our drainage is lacking over here at 3 points. In the middle of the south side yard, this is the north side yard, this is the northeast corner, and then at the southeast corner over by the jet tub and stuff. Moving along through here, our gates are self-closing. Our gates open to the exterior. That's a good thing for the swimming pool. Now, these are the rails. These rails belong on the inside of the fence. I didn't mention this on the swimming pool video, but these fences are installed, essentially, they're inside out. Inside out, meaning that somebody could crawl on the outside. I had a conversation with my client about that. The top rail trim board is kind of loose right up there. Wood mulch next to the house. Paving stones are not dimensionally uniform, so if Granny comes to visit you, you just, help her along, or Grampy. This is for the water heater. So I'm assuming we've got 2 water heaters. This looks like a water heater application. I'm probably going to find a second water heater in the attic. One of these is for the safety pan, I think, and one of these is for the primary drain, for the for the temperature pressure relief valve drain. For the safety pan, that's the proper height from the ground, an allowable, acceptable height from the ground. For a water heater, temperature pressure relief valve, that is too high from the ground. These are called control joints. They should be sealed every once in a while. Moving on along. I tripped the GFCI for the swimming pool equipment, so the lights are on GFCI. I haven't been able to reset it yet, but I got the furnace covers back on. Everything is about like where I found it, so everything is good. I wish I could reset the GFCI. The inspection is not over yet. Let's try. This gate opens into the pool area. Now, my client was discussing, there's a bathroom down there, and they're discussing putting a door where the bathroom window is to come out to this area so people in the swimming pool area wouldn't have to, okay? Well, this gate opens into the swimming pool area. This gate should open the other direction, away from the swimming pool area. All these windows should be self-closing and have a unique alarm system. Now that doesn't come into effect as long as that gate's working over here and you don't have a door and you have a gate over here, you're probably okay. But now, having been said that, then these windows are in the pool area. They should be self-closing. They should have a unique alarm. This is the rain gutter downspout. It's going underground. I like that, but it's kind of cracked. Needs some maintenance. And our water stands and pools over here in this area. And we want the water to run away from the pool. We don't want rainwater running back into the pool. So that's something that we want. But at the same time, so this fence is backwards, I put the cap back on. So, And you don't know which order I do these reports, but I did. Now, a lawn sprinkler head should not be closer to the structure than 5 inches. And it should be closer to the flatwork than 5 inches either. Bring on a lawn. Should be self-closing. Should have a separate door alarm on it. But that's the living space. Actually, that's acceptable for some reason. This should be self-closing. Should have a unique door alarm on it. Wood mulch, wood mulch, wood mulch. There's a dead valley, and that dead valley has, we can see, it has a kick-out flashing, so somehow or another they managed that one. So we got the kick-out flashing over here at the end of the rain gutter butt end. Now the rain gutter butt end, in turn, is supposed to be about an inch away from the wall, and it's not. It's too close. Swings out like it's supposed to. How about that? Self-latching. This is about where we started.